Find the limit. The limit as x approaches pi over 2 from the left, tangent of x divided by the natural log of the cosine of x. If we try to evaluate this using the quotient rule, we'd need to know what's the limit of the tangent of x as x approaches pi over 2 from the left. Remember that the tangent function has vertical asymptotes at all of these pi over 2's. Pi over 2, 3 pi over 2, and so on. And you get these branches of tangent in between those vertical asymptotes. Notice that as x approaches pi over 2 from the left, that the tangent function grows without bound. It goes to infinity, so the tangent of x will be infinite. Now the natural log of the cosine of x, well, as x approaches pi over 2, cosine of x is going to get closer to 0. Remember your unit circle, cosine is the x-coordinate, so as the angle gets closer to pi over 2, the x-coordinate gets closer to 0. Well, and in fact it gets closer to 0 from the right. It's bigger than 0. If you remember your natural log function, the graph of the natural log, as x gets closer to 0 from the right, the natural log function grows in the negative direction without bound. So the natural log of the cosine of x goes to negative infinity. This is an indeterminate form, and we can try to apply LHopital's rule to it. So by LHopital's rule, we end up with the limit as x approaches pi over 2 from the left. The derivative of the numerator, the derivative of tangent of x is secant of x squared divided by the derivative of the denominator. The derivative of natural log of cosine of x is 1 over the cosine of x times the derivative of the cosine of x. That's the chain rule, so negative sine of x. You have to multiply by the derivative of the inside. Now we should simplify this before we try to evaluate this limit. So the limit as x approaches pi over 2 from the left. Secant of x is 1 over cosine of x, so 1 over cosine of x squared times negative sine over x times cosine of x. We're dividing by that. That's the same as multiplying by the reciprocal. So cosine of x divided by the sine of x. One of the cosines will cancel. So cosine of x will have 1 cosine of x left over. So in fact, we have the limit as x approaches pi over 2 from the left. Negative 1 over the cosine of x is secant of x times 1 over sine of x is cosecant of x. If we evaluate those, each one of those, we find that as x approaches pi over 2, the secant of x approaches infinity. The cosecant of x, as x approaches pi over 2, cosecant is 1 over sine. Sine of pi over 2 is 1. The cosecant of x is going to approach 1. Negative infinity times 1, you're certainly still going to approach negative infinity. So in the end, we find that the limit that we started with, namely the limit of tangent of x over the natural log of cosine of x as x approaches pi over 2 from the left, does not exist, and it doesn't exist because the function value gets closer to negative infinity or grows without bound in the negative direction as x approaches pi over 2 from the left.